Okay, let's graph cotangent x this time. So cotangent x is equal to sine, no, cosine over sine. Okay, that's equal to cosine over sine. So whenever sine x is equal to 0, you have the cotangent is undefined, which means you have an asymptote. So where is your sine x equal to 0? Sine x is equal to 0 on x is equal to 0, when x is equal to pi, when x is equal to 2 pi, of course, when x is equal to negative pi, when x is equal to negative 2 pi, those are when the x values, sine x is equal to 0. So here are where the asymptotes would be. So let's draw the asymptotes for the graph of y equals cotangent x. So we have an asymptote at x equals 0. We have an asymptote at negative pi. We have an asymptote at pi. We also have an asymptote at 2 pi. Okay, so we are going to plot these points. So when x is negative pi over 2, your y is 0. And it's repeated over here. Okay, remember cotangent is periodic as well. It's repeated over here and it's repeated over here. Now at negative pi over 4, this is negative pi over 4, between 0 and negative pi over 2. Your y is negative 1. Okay, so again, I'm counting by, the scaling here is by 0.5. So this is negative 1. And when x is, it will be repeated over here. Okay, repeated over here and repeated over here. Okay. And then when x is equal to pi over 4 is between 0 and pi over 2. Here's our pi over 4. Your y is equal to 1. Okay, so this point is repeated here. It is repeated right here and then right here. Okay, so basically in between the two asymptotes, as we have seen with the tangent as well, in between the two asymptotes, we have 3 points that we connect together to form the graph of the tangent or cotangent function. So here is our cotangent function. It's in the opposite direction of the tangent function. Okay, tangent function is increasing while cotangent function is decreasing from left to right. Okay, so let's take a look at a transformation. So how do you graph a cotangent bx minus c plus d? So it is the same way as graphing tangent. Now, the only difference is the asymptotes for cotangent occurs at x is equal to c over b plus pi over bk. For tangent, this is pi over 2b. Okay? But for cotangent, it is pi over b times k, and k is an integer. For tangent, k is an odd integer. Not so with cotangent. It is simply an integer. So it could be 1, 2, 3, 4, and so on. Okay? And we basically have the same strategy for graphing as tangent. So let's take a look at this one. Sketch the graph of one period of the function of f of x equals 4 cotangent pi over 8x minus pi over 2 minus 2. So let us identify our A, B, C, and D, just like we did before. A, B, C, D. So our A is equal to 4. Our B is equal to pi over 8. C is pi over 2. And D is negative 2. And then we get our period. Period for cotangent would be pi over B. So that would be pi divided by pi over 8, or pi times the reciprocal of pi over 8, which is 8 over pi. So for this one, period is equal to 8. Pi cancel each other out. And then the phase shift is C over B. So C is pi over 2. So pi over 2 divided by pi over 8, which is the same thing as multiplying by the reciprocal of pi over 8, which is 8 over pi. So this is equal to 4. Pi cancels out, 8 and 2 cancels out, the 8 becomes 4. Now, what about the asymptote? The vertical asymptotes. Okay. Vertical asymptotes is at x equals c over b, which is the phase shift, plus pi over b times k. Now, k is any integer. Okay, let's see. C over b, that's equal to the phase shift, which is 4, plus pi over 8, which is the same as pi times 8 over pi times k. Okay, when you simplify this, you'll get 4 plus 8k. So let's look at the first asymptote. If k is equal to 1, then you have 4 plus 8 times 1, which is equal to 12. If k is equal to 2, we get 4 plus 8 times 2. That gives us 16 plus 4 is 20. So notice that the difference between successive asymptotes is equal to 8, which is the period. So to get the next asymptote, you just add 8. To get the asymptote before the 12, you subtract 8. So 4 is, x equals 4 is an asymptote. And then x equals negative 4 is also an asymptote. Okay? Because the period is 8. So let's see. Say this is 2, 4, 6, 8, 10, 12, 14, 16. I cannot go to the 20. This is 2. Anyway, we only want one period. Okay, negative 2, negative 4. Our D is equal to negative 2. Let's just scale the vertical axis by 1. So this is our negative 2. Okay, that would be positive 2. Anyway, let's draw our like midline at negative 2, because that's the value of D. This time I started with the midline. Okay, now let's draw our our asymptotes, not intercepts, our asymptotes. So we have an asymptote at negative 4. We have an asymptote at positive 4. Then we have an asymptote at 12. Okay. So we now have here two periods of the graph of tangent. So that would be okay. All right. Now, we're starting off where the midline is. So midway between the asymptotes. So midway between the asymptotes, we have this point. Okay? We have this point. We have this point. Okay? So again, the distances between these points is equal to 8 units, which is the period. Okay, our A, the vertical stretch, is equal to 4. Now, this is a cotangent function, and the cotangent function is decreasing. Your A is positive. So the cotangent function is decreasing. It looks like this. So we go to the middle between midpoint between that asymptote, left asymptote, and your point here in the midline. Midpoint is here. And then we go up 4. 1, 2, 3, 4. And then midpoint between the midpoint intercept, okay? Midline intercept, I mean, and this asymptote is right here. We count 4 units as well. 1, 2, 3, 4. Okay, now these points are repeated on the other end. So we have a point here, we have another point here, then we have another point here. See the pattern? And then we connect. Okay, oops, sorry. And you have the graph of 4 cotangent, y equals 4 cotangent pi over 8x minus pi over 2 minus 2. So that's like 2.5 period. Okay, pause the video and try this one. Okay, let's take a look at this. So A is equal to -3, B is equal to 2, there is no, C is 0, and D is 0. Our period is pi over 2. There is no phase shift. Our vertical asymptotes would be x equals pi over 2k. So k could take on any integer. Therefore, if k is -1, then you have negative pi over 2. And then if k is 0, you have 0. If k is 1, that's pi over 2, and so on. So each of these has a difference of pi over 2. So you just keep on adding pi over 2 to get to the next asymptote. Okay, so here are your asymptotes. And I have plotted the asymptotes right here. Negative pi over 2, x equals 0, x equals pi over 2, pi, 3 pi over 2, and 2 pi. Okay, let's plot the points now. So there are 1, 2, 3, 4, 5 periods that we are sketching here. Okay, so midway between the two asymptotes, you have that intercept. Okay, and it's repeated in each cycle. Now, this is negative cotangent. Now, the cotangent is decreasing. So, since this is negative, your cotangent would be increasing. Okay? So, midway between that left asymptote and the intercept is this. We go down 3 units. 1, 2, 3. Then here we go up 3 units. 1, 2, 3. And then it would be repeated on to um the other cycles. And then we connect. And you have the graph of your cotangent. -3 cotangent 2x. Okay. And that is it for cotangent.